This is lessons 7.4 and 7.5 that are being condensed down a little bit to be covered in one video lesson. So lesson 7.4 is called Parallel Lines and Proportional Parts. So basically what we've got here is you're going to have a triangle that looks like it has another triangle drawn inside of it. And there's two theorems. The one's called the triangle proportionality theorem and the other one's called the converse. I really don't care if you know the names of these or not. Like I said, we're kind of jumping over some of the details. I just want you to be able to use it. So in the triangle proportionality theorem, you are given, so this should be the given information. If segment XY and segment RS or line RS are parallel, then it separates the other two sides of the large triangle proportionally. So here's your conclusion. In any triangle, a line or segment parallel to one side of a triangle separates the other two sides proportionally. So in this picture, if line XY is parallel to line RS, then that would make RX over XT the same ratio as SY over YT. So you're saying this part is to that part as this part is to that part. Now again, we don't really have a good way to show proportional, so it doesn't have to mean that the two parts are congruent on the two sides. It's just saying that they're proportional. So for example, if this was 2 and that was 1, this could be 5 and that could be 2.5 because it's still a 2-to-1 ratio. So as long as the lines are parallel, that will cut the other sides into proportional segments. And then the other way around, if you know that Rx to XT, I should be doing this in black, if you are given that Rx to XT is the same ratio as SY to YT, then your conclusion would be that XY line or segment XY is parallel to line or segment RS. Now again, I really don't care about you knowing the names of those theorems or which one's the converse, which one's a straight one. I just want you to understand that if you know the segments are proportional, that'll make the two segments that look parallel, it'll make them parallel, and vice versa. If the lines are given to be parallel, then it'll make the other sides proportional. Now remember that if these segments are proportional, you could also set up the proportion as XT is to XR, as TY is to YS. It doesn't have to be written in the same exact order as this one is. Any equivalent proportion would satisfy. So here's some examples. Find the value of x. Okay, so we are given, notice you're told that the lines are parallel. So therefore the segments are proportional, and that would be like AE is, oops, didn't mean to make that segment. AE is to EC as, now since you're going from the top part of the triangle to the bottom piece, you'd want to go the top part here to the bottom piece. So it would be x plus 22 over x plus 2. Oh, I should have put that with letters. Oh, okay, sorry. AE over EC equals AF over FB. Now, if we went straight to the numbers, it would say 18 is to 6 as x plus 22 is to x plus 2. Now, you might remember in the last lesson I was talking about how you have to be careful that if you're comparing whole sides of triangles, in the little triangle, you want to make sure you use whole sides of the triangle and not the little parts. It would also be correct to say that AE is to AC as AF is to AB if you knew that the triangles were similar. Well, they are similar because the parallel lines makes those angles congruent and these angles congruent. So if you used similar triangles by angle, you would say 18 to the whole side length of 24 is equal to x plus 22 over the whole side length of 2x plus 24. Now that would work perfectly fine, but this is a little bit shorter way. Just remember that if you're going to use the little parts here rather than the whole side of the triangle, you have to know that these segments are parallel. If they're not parallel, the segments will not be proportional, and then you'll have an incorrect solution. Okay, so for this one, I'm going to go ahead and simplify that to 3 to 1 is x plus 22 over x plus 2. Make sure you distribute when you cross multiply. So x plus 22 equals 3x plus 6. 2x equals 16. X equals 8. Okay, for the second one, determine whether segment BC is parallel to segment DE. So we do not know if these are parallel or not. So what we're given is that this length is 15, DB is 12, AE is 10, and EC is 8. So we want to know, are those segments proportional? So when you compare 15 to 12, is that the same thing as when you compare 10 to 8? Now, again, many different ways to check that. You can just cross multiply and see that they're the same, or you can simplify both sides. So if you cross multiply, it would say 120 equals 120. So those are proportional. And then you could also divide out a 3 and make it 5 to 4, and divide out a 2, and it would be 5 to 4, which also works. Or you can do the 15:12 way and simplify both sides. Because the segments are proportional, that makes the lines parallel. Since the segments are proportional, it makes a true proportion. It does mean that BC will be parallel to line DE. Okay, now, again, there are other ways to set up the proportion that would also work. You could do, rather than 15 to 12 and 10 to 8, you could do 15 to 10 and 12 to 8. Yeah. So 15 over 10, is that proportional to 12 over 8? Well, again, 120 equals 120, so that also would check. Okay, so just make sure you're comparing the correct parts to each other. All right, and then for the next one, notice that we have congruent segments here, which means that this is a 1-to-1 ratio. And then we have congruent segments here. This is also a 1-to-1 ratio. Now, it doesn't mean that the segments on the left are congruent to the ones on the right. It means that the ratios are the same. Okay, so if you compare x to 35, on this one, we're not using the segments on the sides, so this is actually not going to be really a problem from this lesson. This is really using similar triangles. Because the segments are parallel, that's going to make the corresponding angles congruent, and the triangles are similar by angle. Now, you could also say that if you compare the segments, that's a 1-to-2 ratio, and this side is a 1-to-2 ratio. Okay, because it's got two congruent parts there, that would make the whole segment double the short segment length. Now, we could also say that by the reflexive angle here, we could say that the triangles are similar by side angle side. Usually angle is easier, so that's the way that I went. But notice that we're using the segments on the parallel, let me do this, that we're using the lengths on the parallel segments. We're not talking about the sides. For these two theorems, we're talking about how the side lengths compare, I shouldn't say sides, the segment lengths on the sides compare, and how that tells you something about parallel. Here, we're really not using the parallel to get anything about these segments. Okay, we're really using parallel to get similar triangles. The reason this problem is different is, again, because we're focusing on the parallel segments' lengths rather than the lengths of the segments on the sides. So if you were to compare x to 35, well, the little triangle side compared to the corresponding side in a big triangle is going to be 1-to-2. So 2x equals 35. X would be 17.5. Okay, now on this one, we're back to saying because the segments are because the two segments are parallel, that makes the segments on the sides proportional. So x is to x plus 12, as 11 is to, oops, did the wrong thing there, 11 is to that piece. So because that's 33, 33 minus 11 would give us 22. So this way would be saying x is to x plus 12, again, because the segments are parallel. That makes the other sides of the big triangle cut proportionally. X is to x plus 12, as 11 is to 22. Obviously, that can reduce down to 1/2. And if we cross multiply that, we'll have 2x equals x plus 12, x equals 12. Now, your other option is to say, let's use similar triangles. This is another way of doing it. which would also work. The triangles are similar because angle, angle. Again, requiring that those are parallel in order to make those corresponding angles congruent. So the triangles are similar by angle, angle, which means that x to the whole side length, which is 2x plus 12, is the same ratio as 11 to the whole side length, which is 33. So you can still do these by using similar triangles if you prefer. X is to 2x plus 12 as 11 is to 33. Okay, now notice that this one is a 1 to 3 ratio. And so cross multiply 3x equals 2x plus 12, and you've got x equals 12 that way also. Okay, now again, obviously you wouldn't do that same problem two different ways. I'm just giving you two options. You can revert back to the parallel segments, parallel lines making the triangle similar, which we're comparing corresponding sides. So this one is using similar triangles, whereas the other one is using this lesson. So this is parallel segments make sides cut into proportional parts. Okay, mid-segments. I think I mentioned this to you when we were doing a problem on one of the homeworks yesterday. This is very similar to the idea of a mid-segment of a trapezoid. So the definition for a mid-segment is a segment that joins the midpoints of any two sides of a triangle. Okay, it's called a mid-segment. In a trapezoid, there's exactly one mid-segment because in a trapezoid, the mid-segment has to join the midpoints of the legs of the trapezoid. In a triangle, you'll have three mid-segments because a triangle mid-segment just simply goes from midpoint, you can see those are congruent, to midpoint. So RP would be a mid-segment. And then you can see that P is a midpoint, and so is Q. It's got 3 marks there. So this one's a mid-segment. And then you can also see that because R and Q are midpoints, this one's a mid-segment. Now, using what we just talked about, because those segments are proportional, those are in a 1-to-1 ratio, that will make these segments parallel to each other. And you can do that all the way around. So these two would be parallel, and these two would be parallel. So each mid-segment of the triangle is parallel to one of the sides of the triangle that it does not intersect. So if we kind of simplify this a little bit, given a triangle, if you find a midpoint of one side and a midpoint of the other side and join them together, it will force this segment to be parallel to a segment of the triangle that it does not intersect. It's connecting two sides, two midpoints of two sides of the triangle, and it'll be parallel to the one that it doesn't intersect. Now also, because these triangles are similar, you can tell that this is a 1-to-2 ratio, and so that's going to make this a 1-to-2 ratio. So whatever that is, this will be double. So this is called the mid-segment theorem. The mid-segment theorem says, triangle mid-segment theorem, again it's very similar to the mid-segment theorem for trapezoids. Each mid-segment of a triangle is parallel to one side of the triangle, and its length is half the length of that side. So here's an example. If you know that this segment is a mid-segment, you'll know two things. You'll know it's parallel to that side. Actually, by definition, you also know that these are the same and those are the same. And then the mid-segment theorem also says that the lengths will be in a 1-to-2 ratio. So mid-segment compared to the triangle, the original triangle, is in an x to 30 comparison. So 2x equals 30, x equals 15. Hopefully that makes sense. It's just half of the 30. It's going to be half the length of the 30. Notice because you have parallel segments there, it says if the measure of angle L is 85, so if this angle measure right here were to be 85 degrees, what's the measure of angle KJH? KJH is here. Well, we know these are parallel because mid-segments are parallel to a side of the triangle, which means this also would be 85 degrees. What's the reason for that? It would be if parallel lines are cut by transversal, then corresponding angles are congruent. Okay, and you could kind of work your way around and sort of figure some things out there too. The perimeter of the mid-segment triangle. Well, since each segment, here, let me do this up here. Let's say that you knew that this segment length was 5. That would make this one 10. Let's say that you knew that this one was 6. That would make this length 12. And then if this one, oops, it should be purple, this one was 7. That should make this one 14. Okay, so the perimeter of the small one, triangle RPQ, is 12 plus 6, 18. And the perimeter of the big triangle, ABC, is 12 plus 14 is 26 plus 10 is 36. Oh, look, that's not really surprising, right? The perimeter of the small triangle is going to be half the perimeter of the large triangle because a little mid-segment triangle in here, that little mid-segment triangle, each of its side lengths is half the length of a side of the original triangle. So the perimeter, when you add them all up, the perimeter of the mid-segment triangle is 1/2 of the original triangle's perimeter. Again, important, but hopefully not surprising. Okay, and then the last part for lesson 7.4 is really very similar to the triangles where we had parallel segments making the sides of the triangles proportional. This seems to come up a lot in standardized tests. They like to use parallel lines with with multiple transversals there. It says when 3 or more parallel lines cut 2 transversals, they separate the transversals into proportional parts. So in this picture, obviously these are your parallel lines. You have 2 transversals. You've got T as a transversal, and you have S as a transversal. So when you have the parallel lines cutting 2 or more transversals, it will cut the transversals proportionally. So A is to B. On the left side here, we're comparing A to B in the same ratio as C to D. So C to D. It's, again, it really kind of looks a lot like the one we were talking about earlier in this lesson with the triangles having a parallel segment cutting the sides of the triangle proportionally. It's a very similar idea. Okay, now you can also kind of specialize this and talk about one specific case. So if you happen to have parallel lines cutting 2 transversals again, so we still have 2 transversals here. And you know that this ratio is a 1-to-1 ratio. That means that these are congruent to each other, right? If this is a 1-to-1 ratio, then that's going to force all the segments, all the transversals that cut it to be in a 1-to-1 ratio. So that will also make this one a 1-to-1 ratio. So W compared to X would also equal 1. So now you want to make sure you understand it doesn't mean that they'll be congruent to the first group. It just means that they'll be 2 congruent segments on that transversal. Okay, so for this one it says find X and Y. And so again, you want to pay attention to the fact that you're given parallel lines there. And so it will be kind of 2 different ways you can set this up. You can just say on the one transversal, so using this transversal, 5x is to 3x, as on the other transversal, x plus 12 is to 12. So 5x is to 3x as x plus 12 is to 12. Another way you could set that up would be to go back and forth. You can go here, compare those two to each other. 5x is to x plus 12 as 3x is to 12. All right, now you might notice that over here we could cancel the 3 and the 12 in the red one, but when you cross multiply here, you're going to get a quadratic because you're going to get 3x times x plus 12. Not that quadratics are terrible, but most of you would probably prefer to avoid them if you have the option. So in this setup, this is kind of nicer because notice that you actually will have the variable dropping out, which basically means either x is 0 or we're allowed to cancel it. Well, x can't be 0 because that would force these two segments right here to turn out to be 0 length, which doesn't make sense. So we don't have to worry about x being 0. So we can cancel that out on both sides and it makes the proportion much simpler. So it would just simply be 5/3 equals x plus 12 over 12. And then when we cross multiply, we'd have 60 equals 3x plus 36. 3x equals, would be 24, right? And then x would equal 8. If you solved this one, it would go 60x. Oh wait, actually, I was going to simplify, I forgot. Let's go ahead and simplify this and make it 5x over x plus 12. Remember, you cannot divide those x's out because you would be ignoring that term right there. Okay, but you can divide the 3 and the 12 and make it x over 4. So that would be 20x equals x squared plus 12x. And then to factor, you have to get everything on one side. So it would be x squared plus 12x minus 20x equals 0. And it would factor as x, oops, I wasn't paying attention. There's two like terms there. Okay, so hold on. So that should be 0 equals x squared minus 8x. That's better. Okay, and that would make it, taking out a GCF would make it x times x minus 8, which means either x equals 0 or x equals 8. Well, again, x can't be 0, so we'll throw that one out, but then you would have to keep the answer of x equals 8. Now, I'm certain that most of you would believe that the blue way is easier. So just watch out for situations where how you set up the proportion will determine whether the problem is an easier problem or a harder problem. Okay, for this one, not only do we have parallel segments, but we also have congruent segments here, which means that since that's a 1-to-1 ratio, that's going to force this one to also be 1-to-1. Now it's asking you to find x and y. Notice that you can just say 2x plus 4 will equal 3x minus 1, because it's a 1-to-1 ratio, so x is 5. And then we can say 3y equals 2y plus 2, so y equals 2. Now again, we're using the fact that because the 3 parallel lines are cut by 2 transversals, it cuts the transversals into segments that are proportional. So the 1-to-1 ratio on the left side makes the right side 1-to-1. And the last problem from this lesson is, we've got parallel lines there. 5 is to 8 as y is to y plus 2. y equals 5y plus 10. Make sure you distribute the 5. 3y equals 10. Y would be 10 over 3. Now you can write that as 3 1/3 or 3.3 repeating, but again, I don't know really why you would do that. It's perfectly fine as 10 over 3, so I would just leave it that way. Now, again, we could say another option. You could say 5 is to y as 8 is to y plus 2, and it will still give you the same cross product, right? So it's still 5y plus 10 equals 8y. It would take you to there and it'd be the same exact solution. But you can compare those two parts together and then compare those two parts to each other. Okay, this lesson will continue on the back side with what's called the triangle angle bisector theorem. And I don't really mean this lesson, I really mean lesson 7.5, but this is the only thing in 7.5 that we're going to do. So the triangle angle bisector theorem says that if you have an angle bisector of a triangle, it cuts the opposite side, the side that's opposite that angle that's being bisected, it cuts it proportionally. So if you know, this has to be given, if you know that this is an angle bisector, then you can say JK is to KM as JL is to LM. JK is to KM as JL is to LM. Okay, now you could also, if you prefer, you can say JK to JL is the same as KM to ML. Because when you cross multiply, you get JK times ML equals JL times KM. Same cross product as we would get back here. Okay. Most people probably think it's easier to look at, most people seem to think it's easier to sort of focus on one part of the triangle first and then the other part of the big triangle. So just keep in mind, we are starting with this large triangle. Okay, we're starting with triangle JKL. We're bisecting one of the angles. It's cutting the opposite side proportionally. So we've got one large triangle here, given that you have an angle bisector. So because there's an angle bisector, it will cut these sides proportionally. So 25 to 20 and x to 28. 25 is to 20 as x is to 28. I'd probably go ahead and simplify that to get a 5, would be 5 to 4, equals x over 28. 4x equals, I don't know what 28 times 5 is, 140. Divide that by 4. You could divide it by 2 twice. 70 and then divide by 2 again would give you 35. That's the value of the missing segment length. Okay, and now this one, you want to make sure you use just the little part here. Since those add up to 15, you know that that's 5. Again, large triangle, angle bisector. Make sure you check that you have everything you need. And then you can say x is to 10 as 13 is to 5. 5x equals 130. X equals, let's see, it goes in twice, 26. Same answer as if you said x is to 13 as 10 is to 5. That's actually a little easier because this is a 2 to 1 ratio, would mean x has to be 26 to make it work. Okay, so you can either go back and forth this way and this way, or you can stay on one side of the triangle, work your way around. Okay, last one. Again, big triangle, angle bisector. Those two compare same ratio as those two. So x over x plus 7 equals 11 over 17. Now notice I kind of actually went this direction this time. It doesn't matter though, as long as you're consistent. You could also do x plus 7 over x equals 17 over 11. Cross multiply, 17x equals 11x plus 77. 6x equals 77. X equals 77 over 6. And I would just leave it that way. Okay, that's the end of lesson 7.5, and that is the last material that will be on Friday's test.